Welcome back with a new video on the topic of conservation of energy. In our last article we discussed this law conservation of energy theoretically used in escape velocity, where total kinetic energy given to an object will convert into its potential energy or absolute gravitational potential energy. Now in this lecture we will discuss conservation of energy mathematically, and we will prove energy is converted into potential energy and kinetic energy. There is no loss of energy, and one form of energy is converted into another form of energy. Energy is not destroyed, only it transforms its one shapes to another shapes. Let me discuss. Consider this is the surface of earth at height h. There is an object having mass m. There is an object having mass m. This mass is stationary at this situations, so its velocity is 0 and kinetic energy is 0. Here velocity, let's see, this is a point A. Here we consider a point B. This is near to surface of earth, point C. We discuss at 3 points, point A, point B and point C. Total energy is a sum of kinetic energy and potential energy. I want to discuss total energy here, I want to discuss total energy here and total energy here, and finally I will prove total energy at all these 3 points will be equal, similar, identical. It means energy is conserved at any situation, but it convert into potential energy to kinetic energy. Let's start. Here initial velocity is 0, that's why kinetic energy is 0, because kinetic energy is 1/2 mv square. 1/2 mv square is 0. Here height is h, so potential energy is equals to mgh, and total energy, here total energy I will write as E and A subscript as kinetic energy and potential energy, but kinetic energy is 0, so mgh, this is energy here, this is energy at point A. See clearly, this is equals to mgh. Now I want to find here the total energy. Total energy is the sum of kinetic energy and potential energy. What is about potential energy? First I will find potential energy. It is little bit easy. Potential energy here is equals to mg. Here is not height of h, this one is x. Now body is released at this situation, it will cover a distance of x. This is equals to x. Initial velocity here is 0. Initial velocity here is 0. It cover distance x. So this one is h minus x. This one is total, let's say 10. Let's say this one is 10. This is 2. Then what will be this? This is 8. If this is 4, this is 6. It means total h minus x, that is equals to h minus x. This is this one height. So h minus x, this is potential energy at this B positions. What will be kinetic energy at this positions? Kinetic energy at this position, kinetic energy is equals to half mvb square. Vb square, what is Vb? Vb is velocity at these situations. So we apply third equation. 2as is equals to vf square minus vi square. This one is third motion equation. But here is acceleration a, but we are perform in a earth gravitational field where acceleration a is gravitational acceleration, that is represented by g. What is s? This is equals to s. S is equals to x. So 2gx is equals to vf is a final velocity at position b, that is vb is equals to 0 minus initial velocity is 0. So vb square is equals to 2gx. Vb square is equals to 2gx. See it clearly. I will erase it as and put here is equation in kinetic energy. Kinetic energy is equals to half m v square is equals to 2gx. 2 cancel out, and finally we get kinetic energy is equals to mgx. This is kinetic energy at position B. Now total energy is the sum of kinetic energy and potential energy. See here, total energy at position B, total energy at position B is equals to sum of potential energy plus kinetic energy. This is the total energy at position B, and sum out potential energy is equals to mgh minus mgx. I expand this term as mgh minus mgx plus kinetic energy is equals to mgh. Sorry, this one is mgx. So mgx and minus mgx cancel out, and finally we get kinetic energy at total energy at point B is equals to mgh, this one. So here total energy EB is equals to mgh. EB is equals to mgh, this one. See here, equation number 1 at position A, total energy is mgh. At position B, total energy is mgh. This is equation number 2. Now we see at position C. See clearly, I will erase it as. Now motion again start here. Motion again start from here. I am discussing, I am observing these events from this position, not from these positions. I am observing from these positions. Let's say what will be the potential energy, because it is little bit easy to find here. I am discussing only at point C. Let's say potential energy, because height is 0, that's why potential energy is 0. Body nearly touch at the surface of earth, that's why potential energy is 0. What about kinetic energy? That one is equals to, kinetic energy is equals to half mvc square. Half mvc square. What is about vc square? This is final velocity. Again initial velocity is 0. Here initial velocity is 0, final velocity is vc. Applying equation 2as is equals to vf square minus vi square. So a is equals to g, because the motion is in gravitational field in vertical direction toward the center of earth, that is acceleration is g. So what is s? S is total height here from point A to point C, that is equals to h, is equals to vf. What is vf? vc square. What is vi? That is equals to 0. So vc square is equals to 2gh. Now I want to erase here and putting this value in this equation. See here, 1 by 2 m vc square, 2gh, to cancel out, and we get kinetic energy is equals to mgh. So putting values in total energy. Total energy, what is total energy? Total energy is a sum of total energy at point C is equals to kinetic energy plus potential energy, but kinetic energy is equals to mgh, potential energy 0, that is equals to mgh. This is total energy at point C. I write here total energy at point C, EC is equals to mgh. See, these three equations are equal. Here total energy, potential energy mgh. See here, kinetic energy is 0. This result is most important. At point A, kinetic energy is 0, potential energy mgh, and at point C, potential energy becomes 0 and kinetic energy becomes mgh. It means kinetic energy is converted into potential energy. Here kinetic energy mgh, at point C. Kinetic energy is mgh, but when it reach at this position, kinetic energy will becomes potential energy. Or in the reverse directions, here is total potential energy is mgh. When it reach at this surface, total potential energy converted to total kinetic energy. Here I discuss only the case when there is no friction. Friction is ignored. If we discuss friction factor here, then what will be the result about? See here. Let's say at this position, body has a total potential energy mgh. When body move, some of its potential energy converted into kinetic energy and other part work against friction. It means this potential energy is converted into two parts. First, work against friction. When this body goes down, here is air resistance that tries to stop it. That is friction, air friction. So some part of this potential energy is converted into kinetic energy and other work done against friction. So let's see what happened. Total potential energy is equals to kinetic energy plus work against friction, F and H. F is a force and H is a height. We know what is work. Work is a product of force and displacement. This is same as, this is force done by frictions and this is H. This is work against friction, F and H. Work is the product of force and displacement. So total potential energy is converted into kinetic energy and work against friction. Now we discuss in another diagram. This one is same, mgh, and again in third equation mgh. It means kinetic energy, potential energy or total energy. Kinetic energy and potential energy converted to each other and total energy at point A, at point B, at point C remains same. Now see in next diagram what happened here is, let's see, this is position A and this is position B. Here potential energy, here is height h1, here is height h2, this is height h2, this is height h1. H1 is greater than H2, therefore potential energy at this position is greater than potential energy at this position. Therefore change in potential energy is equals to mgh2 minus mgh1. This is change in potential energy at this position here. But what will be the kinetic energy if body release here? If body, let's say this is marker, when I release this marker here, this will move. First of all, its velocity vi is equals to 0, then here velocity v2, some velocity. It means here it will move slowly and here it will move fastly. Here is kinetic energy is very small, here kinetic energy is very large. Kinetic energy, potential energy converted into kinetic energy. Here kinetic energy is very small. When it move, kinetic energy increase up to this one. It means here kinetic energy is higher, here kinetic energy is lower. So change in kinetic energy. Change in kinetic energy is equals to higher kinetic energy at this position 1 by 2 mv2 square minus lower kinetic energy at this position 1 by 2 mv1 square. Okay, it means we putting here values. What will be the kinetic energy? Kinetic energy is equals to potential energy minus work against friction. Putting value kinetic energy 1 by 2 mv2 square minus 1 by 2 mv1 square. This is one is equals to change in potential energy mgh2 minus mgh1 minus work against friction. This is all about energy conservation by adding factor of friction. This is all about energy conservation. Next we discuss our next topic. I think this chapter number 4 is almost complete. Now we discuss our next chapter inshallah ta'ala. Thanks for watching. Allah Hafiz.